Hello everyone, I'm Afiq, a technical sales engineer in PV Solutions, and I will do a demo on the features inside Ansys Discovery for 2023 R1 for structure. So the first demo here will be a piston crank. So we will do a simple static stress on this model, and we also will be highlighting contact features, join and hinges inside Ansys Discovery. So basically in 2023 R1, it provides a variety of tools and options for defining and analyzing contacts such as automatic contact detections and contact visualizations. So back to the model. Here we have defined all the necessary parameters beforehand, as you can see here in this model tree here. So such as material, so we have set it aluminum alloy for all parts. And then we have set it, we have defined a boundary conditions such as a pressure on the piston head. And then next we have defined a few supports. So the first support will be a fixed supports on the other ends of the crankshaft. Next we have a sliding supports on the other end of the crankshaft. And lastly we have a sliding supports on the piston wall. So the third one is to represent as a combustion chambers for this piston. So as for context, right, the by default Ansys Discovery will set all the contacts as a bonded contact, as you can see here, sir. Okay, basically bonded contacts, it will act as a permanent contact for all parts that are touching or interact with each other. So we don't want that because some of it we need to have some sliding contacts. So we can manipulate some of the contacts into different type of contact. So in these cases, we have defined a sliding context here. Basically, you just go here, click edit, and then it will show a few options that you can set it. So basically for the sliding context here, we can see that it's been defined between the conrod and the crankshafts here. So you can manually select the faces and then select the context. So for bonded contact, convert to sliding context. Correct. And then apart from that, we can also create a hinges connections between the pistons and the conrod by going to the simulation tabs here and go to the structural sections here where you will see a join features here. So you just click here and then you can define where is it. So click on that. So yeah, something like this, and then you can select the pieces. Okay. Now let's do a quick run in explore mode to see whether our contact is correctly defined or not. So currently I will be running in explore mode, which will be using a GPU solver to solve the analysis. So this is calling a real-time simulation. I just click starts there. So instantly we can get the result here. As you can see, the green check mark is already finished. So to view the result, is either you can play around here. So you have displacement, volume uses, stress, principal, etc., etc. But we want to see if there any movement on this one. So we hover to the result sections here. So we go to the formations. So you see that part is already in the form states, and then we click animations. So by looking at the result, we can see that the piston is moving according to what we want here. Okay. However, in this model, we are locking the crank motion because in reality, this is not how the piston works. Move. This is we are locking the crank motion so that we can study and look at the maximum stresses occur in this model. So by quickly changing from displacement to one user stresses, we can check. So as you can see here, we are looking at the maximum stress occur between the piston and the conrod. Okay. So there you go for the contact capabilities that are available inside Ansys Discovery 2023 R1s. So we will now take a look on the second demo models here. We will be highlight a few features that are new inside Ansys Discovery, which is the both idealization tools, both preload, connection assessment tools, and bolt and connection monitoring features. Okay. So here we have two shafts here that are supposedly connected by a bolt, a set of bolts here. Okay. So first thing first we need to do is a bolt idealization. So we need to create bolts here. So it's either you do by doing a 3D part of it, or you can simplify by doing a simple representation. So for these cases, we will do an idealized bolt by using the idealized bolt tools. So in the prepare tabs here, we go to the bolt here, we click assign. So basically, we just select the hole that we want to put bolt here. And then automatically, Ansys Discovery will calculate and decide which are the suitable bolt that will be assembled here. So for example, as you can see here, the suitable bolt will be M8 with a grade of 4.6. So this is compliant to the Eurocode. Here are the standards. So this bolt, as you can see here, when we pull apart the dimensions and material properties, there will be showing the shank diameter, head diameter, and head height, as well as the material properties that for this bolt. However, let's say if you don't want it with the 4.6, you can change it to another bolt sizes. So for example, if you want to change to 4.8, you can do. But for now, we will stick on the 4.6. Okay. So basically, that's how we create the idealized bolts. So we can click accept here. However, as you can see here, we have another four similar holes that we need to put bolts on. So instead of doing one by one, just go click here, select similar bolt holes, and Ansys Discovery will automatically select the holes that have the same diameters. Okay, well, click on that. As you can see, we have created an idealized bolt here. So you can view it as a 3D, or let's say, for example, you don't want it, you can hide the 3D. You will really represent it as a line here. Okay. And on the model tree here, we can see that the bolt has been created by using the idealized bolt as well in the physics tree as well. Next, once the bolt is defined, you can add the bolt preload conditions to a model under pretension by clicking. So you go to simulations by clicking structural icon and go to bolt preloads. Okay. So these bolt preloads, after this, you just select the bolt that we have just created here. And here we have the parameters that you can define. So basically inside Ansys Discovery, you can define by using a clamp force or a grip length adjustment or a torque. So for this example, I will just use a clamp force with the value of 100 Newton, for example. Okay, so as you can see, a bolt preload in the boundary constraint has been created. Now exit that. Oh, by the way, we already set a preliminary boundary condition. So there will be a moment here and fixed support here. Now, another thing is we will need to tick a bit on the connections here. So as you can see, it created automatically a bounded context here. We don't want it. We want the context to be sliding. So we click edit and quickly change to slidings because there only one context here. So just click here. So, and sliding contact is automatically created inside Ansys Discovery. So this contact will override this context here. Okay. So for the bolt preload is one of the important factors to consider in the design of the joint and structure that rely on bolts for fastenings. So basically, Discovery provide a tools to simulate and optimize bolt preload to ensure the joints are strong and durable. Okay. Next, before we continue on the next new features, just quickly go to explore modes here and then click start to quickly run through whether this setup is correct or not. Okay, as you can see here, bond stresses, deformations, and animations. So you can see the model is working. Okay, now stop. we can quickly go to the refine mode so that we can access the connection assessments for more to see whether this bolt is passed or not. Okay, just click start. It will take some time, depends on your hardware capabilities. Some will be fast, some will be a bit slow. Okay.
Yeah, just to mention, this is actually running Ansys Mechanical in the background. So, okay, but it's already finished.
Okay, now we can finally access the connection assessment for the bolt studies. So basically, the connection assessment tool allow to validate whether it is passed or not for bolt or bonded contact of the model. It allows visualizations of the connection status based on the factor of the safety, as you can see here. Shear factor of safety, tensor factor of safety. So it offers option to show all here or automatic zoom. So for example, if I click automatic zoom, it will zoom on the selected connections. So yeah, something like this. And then we can quickly run through. So we can see the first bolt pass, second bolt pass, third bolt pass, fourth pass, and the fifth pass. Okay. And then another options that we can do is we can simply export this status to CSV for reporting purposes. Okay. So overall, the connection assessment tool is a powerful tool to ensure that connection between parts of the design are strong and reliable, which is critical to ensure the safety and the performance of the finished products. Next, this one is quite interesting also. We also have a new variable that available inside Ansys Discovery. So we quickly go to the monitor here, select variable. Now, inside Ansys Discovery, you can now monitor the connection of factor safety, the bolt axis stress, shear forces, and torsional moments, as David already mentioned before. Okay. So for example, I just click connection factor of safety here, and then quickly go here and activate that. So basically, we can monitor the both results in the graph formats. We can monitor. So when we do a design updates or model updates, we can monitor the changes on here. Okay. So that's it for the second model. So in overall, the big picture we can see here is we can finally simulate a big assembly much clearer and more concise by using the Ansys Discovery with these new features such as the board definitions and contact definition as well. Okay, and then another thing is which is quite interesting in Ansys Discovery is all these models from Ansys Discovery can be transferred to Ansys Mechanical. So by simply going here, simulation tabs, and click Mechanical here, it can quickly transfer all these models to Ansys Mechanical. So for the sake of the model today, demo today, I already transferred the model beforehand. So as you can see, this is the same model that I have defined inside Ansys Discovery, and all the parameters that I have defined inside Ansys Discovery is also retained. As you can see here, there's a connection of the bolt here. We have a bolt preload here, and in Ansys Mechanical, the bolt idealized element is being visualized as this one. Okay, so let's quickly go here. We look for users, and you can just click solve. You can tweak it however you want according to your requirements. So this is a quick and dirty run inside Ansys Mechanicals. Okay, quickly here, you can see, then you can monitor the result here. So that's about it from my side.